Hi all, myself Shruthi.P, Assistant Professor, Department of Electronics and Communication Engineering, Vedavyasa Institute of Technology. So I'm here to talk about very large scale integrated circuits. So what is VLSI? VLSI stands for Very Large Scale Integration. That means depending on the discrete components such as resistors, capacitors, diodes, transistors, etc. connected are called discrete circuits. Depending on the complexity of the circuit, there are different levels of integration. So next we have to discuss about what is VLSI. That means Very Large Scale Integration. So coming to the level of integration, first one is small scale integration. That is the first one. That means small scale integration. So it uses transistors, it's 10 to 100 range. That means examples are logic gates, flip-flops. Then next level is medium scale integration. In medium scale integration, there are 100 to 1000 number of transistors per chip. The examples are counters, multiplexers, adders. Next one is large scale integration. Large scale integration uses 1000 to 10,000 number of transistors per chip. Examples are 8-bit microprocessor, RAM, ROM. RAM means random access memory, ROM means read-only memory. Then next is very large scale integration, that is VLSI. It uses 10 raised to 4 to 10 raised to 7 number of transistors per chip. Examples are 16 and 32-bit microprocessor, then DRAM. DRAM means dynamic random access memory. Next is ultra large scale integration. It uses 10 raised to 7 to 10 raised to 9 number of transistors per chip. Examples are special processors. So we are discussing about very large scale integration. Then based on this, there is a law that is called Moore's law. That means every 2 years the number of transistors increases. Based on that, it's the law Moore's law. So next we have to discuss about ASIC, that means application specific integrated circuit. Generally, an ASIC design will be undertaken for a product that will have a large production run, and the ASIC may contain a very large part of the electronics needed on a single integrated circuit. That means ASIC means application specific integrated circuit. Examples are Examples of ASIC ICs are a chip for a toy that talks, a chip for a satellite, a chip designed to handle the interface between memory and a microprocessor for a workstation CPU, and or a chip containing a microprocessor as a cell together with other logic. So ASIC means application specific integrated circuits. Advantages of application specific integrated circuits are its size is small. We know the application specific integrated circuits are small. Example is in the car, there is a toy car, there is a small chip. As a large number of circuits are built over a single chip, this causes high speed of application. ASIC has low power consumption, and also ASIC has no timing issues and post-production configuration. Then there are different types of application specific integrated circuits. First one is full custom ASIC, then semi custom ASIC, then programmable ASIC. Next one is semi custom is also classified as standard cell based ASIC, gate array based ASIC. Programmable ASICs are classified as PLDs and FPGAs. PLD means programmable logic devices and FPGA means field programmable gate arrays. This gate array based is also classified as channel, channelless and structured gate. These all are application specific integrated circuits. Next is system on a chip, that is SoC. SoC consists of input output ports, mainly CPU, internal memory, analog circuit, on chip interconnections, ASIC logic, and then SoC is an integrated circuit that integrates an entire electronic system onto it. The components include a central processing unit, input and output ports, internal memory, analog circuits, on-chip interconnections, ASIC logics and software. Instead of a system that assembles several chips and components onto a swing circuit board, SoC fabricates all necessary circuits into one unit. That means it's a system on a chip. That means entire system consisting on a single chip. That's depending on the kind of system that has been reduced to the size of a chip. It can perform a variety of functions include signal processing, wireless communication, artificial intelligence and more. The parts include CPU, that means central processing unit. System on a chip has a processor at its core which will define its functions. That means CPU is the central part of SoC. It can have more than one processor, that is application specific instruction processors, intellectual property cores, digital signal processors, etc. Then next one is memory. Memories allow the chip to store program and data. It may have RAM, ROM, EEPROM, flash memories, etc. Then connectivity module bar interface means SoC include external interface for communication protocols. It includes Wi-Fi, USB, UART, Bluetooth, etc. Also when needed, it include ADCs and DACs. ADC means analog to digital converter, DAC means digital to analog converter. Then advantages of SoC are low power, low cost, fast operation, small size, high reliability. Disadvantages are high fabrication cost, difficulty in packaging, more heat dissipation. So these all are about very large scale integrated circuit. Thank you.